All right. Okay, guys, it's starting. Okay, here we go, guys. Okay, 3, 2, 1.
Lights, camera, fraction, and variable.
Okay.
And math.
So calm down, guys. So we've already talked about fractions and equations and solving equations, right? But there are certain kinds of equations that tend to be a little harder to solve, especially because they have fractions in them. There is a really, really cool trick that I'm going to teach you today that allows you in one move to get rid of all fractions out of your equation. Okay? And so if I gave you a fraction, an equation like this, 4. Let me see. 4/5 x plus 1/5 equals 10. Okay, so you got 4/5 x plus 1/5 equals 10. All right, now if I was going to keep them as fractions, it would be a little harder to solve. It would still be solvable, and it's still not that hard, but it would be a lot easier to get rid of the fractions. Wouldn't you agree with me?
Yeah.
If we could just in one quick move get rid of the fractions, right? So this is what you do. This is the cool trick. Cool trick. Now this only, I'm going to just mention something. This only works when the fractions are in an equation, right? Now if I just gave you a fraction, or like 1/2 plus 3/5, you can't just use this trick. Okay, so
there has to be an equal sign for the trick.
There has to be an equal sign for the trick to work.
And it always works when there's an equal sign?
Yes, and it's because of a rule, which I guess it's in my classroom over there, which is the golden rule of algebra, which says whatever you do to one side of an equation, you do to the other side of the equation, right? Do unto one side of the equation as you would do unto the other. It's an amazingly valuable rule, yes.
What if you don't want to do the same thing?
Tough. Then you no longer have an equation, right? That's the problem. So this is the cool trick. Multiply every term by the denominator. So today we're focusing on ones where the denominators are the same, okay? And then maybe tomorrow we'll talk about them when they're different. But the main thing is to just get used to this little trick. So it says multiply every term by the denominator. That's kind of weird, so guys, calm down. So what is the denominator, Skylar? I need you to focus more, okay? You can't keep doing this, otherwise I'm going to have to move you somewhere else, right? You got to stay focused. So what is the denominator?
5.
5. Okay, so I'm going to multiply everything times 5. Is 5 a whole number?
Yes.
When you multiply a whole number times a fraction, where does that go?
On the top.
Is that right? On the top?
No.
For sure?
The denominator.
If I multiply one, I'm just going to see for a second. 4/5, and I'm multiplying this times 5. How would I write that as a fraction? 5 over 1. Oh, yes, so 5 does belong upstairs, right? Is everybody clear on that? Everybody sees that? So, therefore, since 5, if it's a whole number, it belongs upstairs, this is what I'm going to do. I'm going to write times 5 in the numerator. You see that, what I did? And then over here, I got to do the same thing here. I've got to do it to every term. This is a term, this is a term, this is a term. If I don't do it to every term, I just destroyed the equation. It is no longer equal. Okay? So it's really important. So I'm going to put my times 5 upstairs in the numerator, just like that. And here I don't have a numerator. I don't care. I'm just going to put times 5. So John, write these down in your notes. You got to be sure. All you guys, make sure these are written down. Now, I could multiply 4 times 5 is 20, and then 20 divided by 5 is 4. But look what I could also do. The 5's cross out, right? Which means, because 5 divided by 5 is 1, 5 divided by 5 is 1.
Only multiply numerator?
Only the numerator.
Okay.
Only the numerator. If I multiplied the denominator too, I'd just be multiplying times 1. It's because of the golden rule of algebra that this is legal. I am changing the values on both sides, but I'm not changing the equality of those values because I'm multiplying everything by 5. Does that make sense?
Yeah.
Okay, so now look at this. These 5's cross out. That's interesting, right? 5 goes to 5 ones, 5 goes to 5 ones. And then, okay, that'll be 50, right? So look what I have. I have my numerator, 4x. 4x plus 1 is equal to 50, right? Subtract 1, subtract 1. I've got 4x is equal to 49.
Which is 12.25.
Divide by 4, x is that, right?
It's 12.25.
All right, so we could either say 49/4, that would be legal. That's an acceptable answer. Or you could say 12 point what? 25. Okay, or yeah, something like that. Or you could say 12 1/4, right? You could also say or 12 1/4. Right? All of those would be sufficient answers. I'm fine with the fractions being improper fractions. And you can just leave that as your answer. If you need to know what that is, because you have to graph it or something, then yes, it would be helpful to have this number. But in algebra, oftentimes fractions are more valuable, more useful than the actual mixed number, right?
Can we just multiply it by 4 then? And then multiply x by 4? And then have 4x, 49 times 4.
What?
And
Sorry,
then,
start over again. Start over.
couldn't you like do the thing that you did with the fractions? You could like multiply 49 times 4, and then
Yeah,
times
but the
x
reason that
times
those
4.
4's are there is because I was just trying to solve the problem. Because I
Yeah.
had 4x equals. But you're right. If I multiply both sides times 4, then I have 4x equals 49.
No. If you multiplied 4 times 49 and x times 4.
It would.
Oh, you mean cross? You mean the like?
No.
No, wait. You can't come up here. You can't because I got the film.
What?
You're talking about like this cross multiply?
No. Once it's already solved, like x equals
Oh, this.
49
Okay.
over 4,
Yes.
then multiplying 4, and then multiplying that by 4.
Look at his paper. He has enough for you.
Yeah, that would work.
Then
But
we'll
then you'd have 4x equals whatever that is. Whatever that is. Maybe you just divide again, and that would probably get the same answer.
No, you wouldn't.
But if you did that, then you'd have 4 times this over 4 times 4, which is 16, right? So then you'd have to divide by 16. Right now it's just 49 divided by 4, which is what a fraction is. Every fraction is a division problem, right? Okay. All right. So let's try a few.
I knew that.
So let's try a few and get this down really, really well. Okay. So everybody, make sure every single problem is in your notes. Absolutely every single problem, all the way from the beginning to the end. So you can see exactly how I'm expecting to see it. Because I'm going to look at. I want to be able to see what you're multiplying by and where it is and how you crossed it out. Okay. How about I gave you, 7x plus. Wait a minute. Yeah, 7x plus 2/9 equals 10. Okay, there's only one fraction in this one. What's the denominator?
9.
So I got to multiply 9 times this term, 9 times this term, and 9 times this term. So immediately this times 9, I'll do it this way. This times 9 upstairs, and then this times 9. I want to see the times 9 on all your. I want to see this step all the time. So 9 times 7 is 63x. Now these 9's cross out. 9 over 9 is 1. I don't need them. So then plus 2 is equal to 90, right? Now I just subtract 2, and I have 63x is equal to 88.
Question mark?
Divide by 63, x is equal to 88 over 63. If I could simplify that, I would, but I don't think I can. Well, actually,
3?
yeah, I don't think I can. 3. Oh yeah, I guess I could. 3 goes in both of those. Is that right? No, 3 doesn't go to 88. No.
Technically,
Okay. So yeah, I'll just keep it like that.
it's 1.4. Yeah.
4, 1.4.
It's 1.4.
Okay. So let's do. Can I erase?
Yes. Yeah.
Can I erase, everybody?
Yeah.
Yeah.
For sure.
Yes.
All right. How about this? Y. No, excuse me. Sorry. What if I gave you 2 11ths x plus 6 11ths equals 10 11ths?
Oh gosh.
Oh my God, this one looks hard. This one is extra hard, right?
You get
Extra hard.
2x.
What's my denominator? 11. So I'm going to multiply times 11. These cross out. Times 11. These cross out. Times 11. These cross out. Oh my God. That means all I have left is my numerator. 2x plus 6 equals 10. 2x plus 6
That's so easy.
equals 10. Minus 6 minus 6. 2x equals 4. Divide by 2.
X equals 2.
X equals 2. Look how easy that was. Right? If you had chosen to just do it with fractions, it would have been fine. You would have been able to do it, but it would have taken more time. Right?
Potato.
Can I erase?
Yes.
Are you writing these down?
Yes.
Okay. Every single one, make sure they're all written down so you get used to it. All right. How about I give you this? How about 2
Fifths.
Sure, that's fine. 2/5 x. Let me think. What am I doing? Okay, plus 4 equals
99.5.
we'll just say
Why so much 10?
10/5.
Why so much 10?
Why so much 10?
Why so much
Why
10?
much 10 so?
All right, so what's my denominator?
You should
5.
5. So I'm just going to go times 5. Those cross out. Times 5. Times 5. Those cross out. So I have 2x plus 20 is equal to
10.
10.
Wait, no.
So subtract 20. Subtract 20. I have 2x is equal to what?
Negative 10.
Negative 10. Divide by 2. Divide by 2. X is equal to what?
Negative 5.
Negative 5. So easy when you use this method, right?
Well,
It's so easy. Fist to 5. Do you understand the method?
Yes.
Very much method.
Fist to 5.
much math, such method.
Very much method.
Very cool. You guys rock. Okay, I think that's it for the lecture.